Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at 3.10. This is one of two videos. In this first video, we are going to be covering how to evaluate inverse trig functions. If you need to understand how to take an inverse of a trig function, please watch the other 3.10 video. This is purely about evaluating trig functions and finding those values using these inverses. Well, notice we have a unit circle here. And what we want to do is understand what an inverse does. Well, an inverse we know is just kind of a process that's used in solving. It's something you do in order to move things around in an equation. So for example, if we had something like this, if I had maybe sine of theta equals y, and I wanted to get theta by itself. Well, what I would do on both sides is I would take sine inverse, because that's the opposite operation of sine. Remember, opposites undo each other. That's how we move things to the other side, right? Multiplication and division undo each other. Addition and subtraction undo each other. Inverse operations undo each other. So I take the inverse on both sides here, and that gives me sine inverse of theta. Notice this notation, the -1 is the inverse part. That's what tells us this is an inverse. Sorry, that should have been a y on the inside. So notice what we are doing then. When we are looking for theta, when we are taking sine inverse or cosine inverse, what you are doing is you are solving for an angle. Anytime you take an inverse trig function, you're solving for the angle. So for example, when I look at some of these problems now, for example, A says find the exact value of sine inverse of 1. Another way you might think of this problem here is sine of theta equals 1, just by moving the sign back to the other side. So we're trying to figure out what angle for theta gives us the sine value as 1. Okay, well now there's some other stuff that I need to think about because this is confusing, right? This is complicated. Okay, well we know sine is y. So I'm wondering here, what angle creates or gives a y value of 1. When you take an inverse trig, what you are asking yourself is what angle gives you a specific value. But in this case, we're looking at sine. We know sine is the y value. So what angle gives a y value of 1? Ideally, we can do this without the unit circle, but let's start by utilizing it. Well, what angle gives a y value of 1? Y is 1 up here. Well, what angle was that? The angle was pi halves or 90 degrees. That is the theta value that we were looking for. Let's look at B. B says sine inverse of -1/2. So what angle gives a y value of -1/2 now? So again, we look at the unit circle. I want what angle gives a y value of -1/2. I'm looking around, I see -1/2. I'm looking around, I see -1/2. Here we go. There's two different values. But when you talk about inverse functions, sometimes you use all of these angles, sometimes you don't. What we are doing right now is we are restricting the range of these values. So I'm not looking between this entire unit circle. I'm only looking at specific parts depending on sine, cosine, or tangent. For sine, I am only using the first quadrant and the fourth quadrant to evaluate these. Cosine, we're using quadrant 1 and 2, and tangent, we are using quadrant 1 and 4. So when I look at this then to evaluate, I do not care about that 1 in quadrant 3. I care about the 1 in quadrant 4 because, again, this is sine. All I care about are these ones. So, okay, what angle gave me that? Well, it's 11 pi 6, and that's not the right answer. It's a good answer. It is true, but what we need is something that is in this range, negative pi halves to pi halves. So I don't want to say it's 11 pi 6 because that is almost 2 pi. That's definitely outside of this range. So instead, I need to be more creative. Well, we know that if I start at 0 and I go backwards, that is a negative angle. So really what I am doing is I am going negative pi 6 to get to the angle that we care about. There is sine inverse of negative 1/2. Let's look at C. C says cosine now. So now I'm asking myself, what angle gives an x value, right? This is cosine now. An x value of negative root 2 over root 2. Notice cosine, we restrict it differently. So now for cosine, I am only curious about this top part of the unit circle, quadrant 1 and 2. So, okay, we want negative root 2 over 2. This is an x value. Look at each of the x values, and I see it's here. This value is in the range of 0 to pi. So now we have our answer, which is 3 pi over 4. Same idea for the next one. What is the x value? What angle gives you an x value of 1/2? Well, an x value of 1/2 is right here. The angle that does that is pi thirds. When you do an inverse trig function, you are finding the angle. Tangent's a little bit weird, so let's break that one down real quick. Let's figure out what the tangent value is at each of the spots in the first quadrant. Remember, tangent, we know, is always y over x. So if I take the y coordinate here, that's root 3 over 2 over the x value of 1/2. The 2's cancel, so it's root 3 over 1, which is just root 3. Anytime that you have a tangent function that gives you root 3, it will always occur at pi thirds. Anytime you get root 3, it'll always be at pi thirds for tangent. Well, okay, we can do the same sort of logic for this one now, where, okay, the y value 1/2 over the x value, simplify that, rationalize it, and now we have this. So anytime that you get root 3 over 3 for tangent, we know that that will be at pi 6. Realize why that makes sense? Tangent is really just finding the slope at some point. Well, root 3 over 1 must be steeper than root 3 over 3 because of the denominator, right? Root 3 over 1 is a larger value, so it is increasing faster. Pi thirds is a steeper angle than pi 6. It is increasing faster. Tangent is just the slope, like I said. Pi fourths, we should already know our tangent value there, root 2 over 2 over root 2 over 2. We know that is just a value of 1 there. Tangent at 0 would be 0 over 1, which is 0. And up here, it would be 1 over 0, which is undefined. Those are the tangent values at each of the spots in the first quadrant. So when I look at E, and they say, okay, what is tan inverse? What is the angle that gives a tangent value of 1? Okay, well, a tangent value of 1 is right here. What angle was that? That was pi fourths. There we go. We get our answer. We found the angle. F, tan inverse of negative root 3 over 3. Well, I know root 3 over 3 is pi 6. So if I want the negative version then, I must go into a negative area. Well, notice tangent, we know, is restricted between here and here, quadrant 4 and quadrant 1. So if I want negative root 3 over 3, that must occur here. So now what that tells me is I'm at 11 pi 6, but again, we don't like 11 pi 6. It needs to be in the correct range. So in order to get to that angle, I would just go in the negative direction instead. Our last one then, negative root 3 over 3. This one would be negative 1. This one would be negative root 3. So yes, 5 pi thirds seems like a decent area, but put it in the correct range. That means I'm rotating backwards to pi thirds. Negative pi thirds would be my answer. This is how we can evaluate inverse trig functions. Last thing, example 2 here, find the exact value of the expression. Here you need to make sure you are in the range. Pretty much just do the order of operations. So let's start with the inside. Well, what is sine of 5 pi thirds? Well, sine is the y value. So what is the y value at 5 pi thirds? Let's go to our unit circle. Let's see, I'm going to use a different color now. 5 pi thirds is over here. What is the y value? That's negative root 3 over 2. Okay, so what we just did is simplify the inside. So now this is sine inverse of negative root 3 over 2. Okay, but it's sine inverse. So now I'm thinking angle. What is the angle that gives me the y value, negative root 3 over 2? Okay, well, let's think. Let's go to the unit circle. Sine, I do need to be in the restricted area. Negative root 3 over 2 is still that same spot. It's still 5 pi thirds. And that makes sense because it's sine and sine inverse. Those two parts really cancel. But we need to go in the correct range. So we need to just go backwards to that instead. So our answer would be negative pi thirds. Cosine of this next one, we're at 6 pi. Well, 6 pi is 2 pi, 4 pi, 6 pi. So that's just 3 circles around the unit circle. So really what we're doing there is finding cosine of 0. Cosine of 0 is just 1. So we want to know, okay, cosine inverse of 1. So cosine inverse of 1, what angle on the unit circle gives us an x value of 1? And that would just be 0 degrees. Let's look at one more example. For this tan inverse of tangent 5 pi fourths, 5 pi fourths is in the third quadrant. So I know that it's at pi fourths, so I know tangent must be equal to 1. In the third quadrant, negative over a negative, right? This would be negative root 2 over 2, and negative root 2 over 2 cancels to just give me positive 1. So now I want to know what angle in our restricted domain gives us a tangent value of 1, and that would just be at pi fourths. Thank you for watching this video. Again, there is a second video for 3.10 looking at finding inverse trig functions, not just evaluating. Thanks for watching.